Since the beginning of our education, we've been told that the Earth is not stationary, and it is actually constantly moving. The Earth rotates around an axis and revolves around the Sun. But why does it do this? And why does it never stop? Did you know that dinosaurs used to experience 22-hour days when they were alive? This means the Earth actually slowed down. But why? To understand this, we must understand why the Earth spins in the first place. Millions of years ago, space debris and dust collided, and as it collided, it started to spin. This caused the momentum to go up and get conserved due to the conservation of angular momentum. Angular momentum is a quantity of rotation of a body. It is what allows the Earth to rotate around its axis. Additionally, the Earth was born spinning, and will remain spinning according to Newton's first law and inertia. Newton's first law says that an object at rest will remain at rest, and an object in motion will remain in motion with a constant velocity unless it experiences a net external force. Inertia is the tendency for an object to maintain its motion and not accelerate. And this is why the Earth has always spun. The Earth was born spinning, so it will always spin. However, its velocity will not always remain constant because there are forces to disrupt its inertia. Factors like the tidal pull of the moon and meteors have ultimately caused the Earth to lose a little bit of inertia, which has caused it to slow down from the time of the dinosaurs. Now let's understand why the Earth rotates around the Sun. The Sun is huge and has a very strong force of gravity, so why doesn't the Earth just collide with it and burn up? Well, planets move sideways as well as perpendicular to the force of the Sun's gravity. So as the Sun pulls this way, the planets instinctively move this way, and this motion is the Earth's tangential velocity. Tangential velocity is the instantaneous linear velocity of an object directed along the tangent to the object's circular path. And this can be modeled by the equation Vt equals r omega, where r is the radius and omega is the angular velocity, which is also equal to change in theta over change in time. In fact, we can measure the tangential velocity of the Earth using another equation, 2 pi r over t, where r is the center-to-center distance between two objects and t is the time it takes for the object to make an orbit around the circular path. And using this equation, we can find out that the tangential velocity of the Earth is about 30 kilometers per second. The Earth also has a centripetal acceleration, or center-seeking acceleration. This is the acceleration directed towards the center of the circular path, or in our case, the force of the Sun pulling the Earth towards it. With this comes a centripetal force, a force directed towards the center of the curvature of path. In Earth's case, the centripetal force is the gravitational attraction between the Earth and the Sun. While this is a very large force, it is not large enough to overcome the linear velocity of the Earth. The Earth will not ever fall until the velocity decreases, just like a spinning rubber stopper on a string. And numerical values of each, centripetal acceleration can be modeled by the equation Vt squared over r meters per second squared. And centripetal force can be modeled as summing all of the centripetal forces and setting it equal to the mass times acceleration, or as a centripetal force equals the sum of all of the in forces. Since we know that the centripetal force between the Earth and Sun is the Sun's gravitational attraction, we can find this by using Newton's universal law of gravitation. And this can be modeled by the equation g m1 m2 over r squared, where g is a constant equal to 6.673 times 10 to the power of negative 11 Newton meters squared over kilograms squared. M1 and M2 stand for the masses of the two objects, and r is the center-to-center distance between the two objects. And from this equation, we can find out that the gravitational force between the Sun and the Earth is 3.543 times 10 to the power of 22 newtons. So there you have it, why the Earth rotates and revolves. Remember, it rotates around its axis because of the law of inertia, and it revolves around the Sun because of its tangential velocity. Thanks for watching.